Ever since ChatGPT took over the world, people on the political right have complained that it has a political bias that leans to the left. But maybe people on the political right are just whining more loudly about how unfairly they're being treated. Or maybe they spend more time looking for examples. And in any case, it's not like ChatGPT is the only large language model out there. What about the other ones? Didn't some rumors say that Meta leans to the right? Well, a recent study has now tested the political orientation of all popular large language models. And it's found some surprises. Let's have a look. There have been many examples of ChatGPT's biases. For example, it doesn't like to admit that a left-wing news outlet is left-wing, but it'll readily explain why a right-wing news outlet is right-wing. In some instances, it's clearly not a matter of training, like when it refuses to explain why women are dishonest, but not why men are dishonest. ChatGPT isn't the only chatbot with issues. Meta's AI recently made headlines for claiming that the Trump shooting didn't happen, and Musk's chatbot Grok on X Twitter recently spread election disinformation. Oops, just an odd mistake or indicative of a systematic trend. If you think that Musk's Grok bot will probably lean to the right as much as ChatGPT leans left, well, brace yourself. The new study comes from David Rosado from New Zealand. He looked at 24 large language models, including GPT, Claude, Gemini, Meta's Llama, and Grok. He put them through a series of political orientation tests, creating what's the most comprehensive study of AI politics to date. I also took these tests both for your amusement and because I wanted to get an idea what they were all about. First, there is the political coordinates test, on which I end up being a right libertarian. My mum would be shocked. The AI models almost all end up being left liberal. Who knew silicon could be so progressive? The one hanging out into the right side? No, that's not Grok, that's Perplexity. And the one on the liberal end? That's Grok in fun mode. Then there's the political compass test, on which I'm a left libertarian, like pretty much all large language models. GPT-4 is the green downwards triangle, so somewhere in the middle of the pack. The one on the left libertarian end, yes, that's funny Grok again. Did you expect it to lean left? I didn't. Plot twist, Elon Musk is secretly a communist spy. Then there's the Eysenck political test, on which I come out to be traditional and tender-minded, which I guess means that my brain is particularly tasty. No, hang on, it means moderately conservative. The AI models all trend into the social democrat and left liberal corner, and the most extreme one is again Grok in funny mode. And finally, we have the political spectrum test, on which I come out a centrist social moderate. I think this basically means nowhere in particular, and is where I'd place myself. It's worth mentioning that this test differs from all the other ones in that it lets you give a weight to how relevant you think a question is. Interestingly enough, this removes most of the libertarian bias of the AI models. The one that sticks out into the authoritarian sector, that's Grok in normal mode. So as you can see from these results for the large language models, they very systematically trend towards a particular side of the political spectrum that's left liberal. Looks like the robot revolution will come with universal basic income and free charging stations. But why is that? One possible explanation is a bias in the training set. Maybe the left liberals just write more so that their opinions get more reinforced. Another possible explanation is that the models have guidelines to produce unoffensive output, and by my impression the political left tends to be more touchy about language use in general because the world has no bigger problems than pronouns. So if you were trying to create a chatbot, you'd quite plausibly program it to please the left more than the right, wouldn't you? The author of the paper is pretty convinced that this is what's going on, and he has a good reason. He says the data show that the political preferences are more extreme for models that have gone through adjustments after the training was completed. He writes, "These political preferences are only apparent in large language models that have gone through the supervised fine-tuning and occasionally some variant of the reinforcement learning. If nothing else, then I guess my mixed results explain why I'm constantly being accused of being both left-wing and right-wing and a Marxist, liberal, feminist, Nazi and whatnot. I think we need a political quantum orientation so that you can hold all political positions at the same time as long as no one asks. And when the next election comes up, you don't even have to vote because whatever you want, it'll happen in some universe. I've gotten a few complaints that I don't talk about particle physics anymore. It's because there's nothing to talk about. But this week we have a new anomaly, oh yes, and it's a crazy one. It's too much antimatter in space. Let's have a look. This anomaly doesn't come from the Large Hadron Collider and not from any particle detector either. It comes from a charmingly small experiment called the Alpha Magnetic Spectrometer, AMS for short. What makes this experiment special is that it's aboard the International Space Station. That's an advantage over Earth-based detectors because this way the AMS detector gets to measure particles which come from outer space before they hit the atmosphere of our planet. This is great because particles that enter the atmosphere of our planet usually scatter on air molecules and create very complicated showers of thousands of particles. It's then very difficult to reconstruct what the original particle was made of. The AMS, in contrast, can measure particles like they come from outer space. And they've detected, I hope you're sitting, ionized anti-helium. Yes, the nuclei of anti-helium, that's 2 antiprotons plus 2 antineutrons. This is mind-blowing because antimatter is already rare, so anti-helium should be super rare. So rare indeed, we shouldn't see it at all. But what is antimatter to begin with? Each particle in the standard model has an antiparticle that's its identical twin, except it has the opposite electric charge. The electron, for example, has an antiparticle called the positron. Antimatter then is stuff made entirely of antiparticles. When matter meets antimatter, they annihilate, and that process releases a lot of energy in the form of very fast particles, mostly photons. This is why antimatter is so rare. If it comes into existence at all, it annihilates quickly. Or to put it differently, when matter meets antimatter, it's less Romeo and Juliet and more boom, there goes the neighborhood. Antiparticles can and have been created in particle colliders. They have also been found in cosmic radiation reaching us from outer space, and they are naturally produced in some types of nuclear decay. CERN has an experiment in which they produce antihydrogen. That's an antiproton with a positron around it. They create it by diverting part of the collider's proton beam and slamming it into a metal target. CERN, creating the universe's most expensive couples since 1954. So physicists thought they understood antimatter, and now this. The AMS experiment has detected a total of 10 anti-helium nuclei of 2 different isotopes, both helium-3 and helium-4. This is way, way more than they expected. So where does the stuff come from? We do know a lot of mechanisms in astrophysics that create the occasional antiparticle. Actually, pretty much every larger collision has some chance to create antiparticles. The thing is, though, that they're normally single elementary particles and they're moving very fast. It's unlikely already to get a single antiproton, not to mention 2 antiprotons and 2 antineutrons, and to have them be so close and slow that they can bind to an antihelium. We've seen antihelium before. The RIC experiment in Long Island in the United States has detected a total of 18 helium antinuclei. But this experiment is designed to create vast amounts of particles in heavy ion collisions, and they measure them very quickly. It's not the conditions that you expect in outer space. Indeed, the fact that the anti-helium nuclei that we have seen do what physicists expect just makes the AMS measurements even more puzzling. This isn't an entirely new story. The first AMS anti-helium detection dates back to about 10 years ago. But you know, if you make one freak measurement, then that might just be a freak measurement. At this point, it's definitely very weird. How do they know that that's what they measure? They send the incoming particles through a magnetic field. They measure the path, and the curvature of the path depends on the ratio of charge over mass. And when the particle hits the detector, they measure the energy deposited, which gives them the mass, so they can then calculate the charge. Where might the anti-helium come from? Pretty much all speculations I've seen say that the anti-helium is created by some sort of dark matter. One idea is, for example, that dark matter can decay into a lot of very slowly moving quarks. This could increase the expected anti-helium ratio by almost 1,000,000 and potentially explain the observations. Another idea is that it could be decaying tiny black holes. Yet another idea is that dark matter can locally create big plasma balls that spit out chunks of antimatter. Personally, I think it's leftovers of the nihilists' anti-party balloon, submitting to PRL now. A few weeks ago, I finally came around to buy a few Nvidia stocks because, hey, I also want to get something out of the AI boom. These stocks have been dropping ever since. Why? Oh, right, I don't believe in God. Yes, so it doesn't look good for AI at the moment as investors are panicking and stocks are dropping. But in this video, I want to make a case that this bubble, which is currently bursting, is not that of AI per se. It's that of the specific type of AI called large language models. I'm sure AI enthusiasm will resume once people get it into their head that there's more to AI, and my stocks will recover. The best known problem with large language models is what's become known as hallucinations. They sometimes confidently ramble along and produce nonsense. You'd think we all learned this lesson in 2022, but then there was the lawyer who used ChatGPT to cook up a defense and ended up citing cases that simply didn't exist. Whoops! Large language models have become better at avoiding some obvious pitfalls. For example, if you ask ChatGPT for book recommendations, it'll now list books that actually exist. It still often refers to made-up papers and reports, though. And Midjourney now, for the most part, puts 5 fingers on each hand, so much so that if you explicitly ask for a hand with 6 fingers, it'll still have 5 fingers. You can do this by tying some output closely to the training set. That might make the problem appear solvable, but it's not that simple because hallucinations are just one symptom of a much bigger problem, which is that for a large language model, correct output is, in a quantifiable sense, close to wrong output. A very illustrative example comes from Colin Fraser, who's been using modified versions of kindergarten riddles like the wolf, goat and cabbage problem. In this riddle, the farmer has to get all 3 in a boat across the river, but the boat will only carry 1 item in addition to the farmer. Left unattended, the wolf will eat the goat and the goat will eat the cabbage. The solution is that the farmer has to take one of the items back on a trip. If you ask a large language model this question, but leave out the information that the wolf will eat the goat and the goat the cabbage, then it'll still give the same answer, which now makes no sense. I like this example because it's obvious what's going wrong. By way of word content, the altered riddle is similar to the riddle that the models have been trained on. So they extrapolate from what they know and spit out an answer that's close to the answer for the original riddle. But as with hallucinations, these answers are close in a sense that we don't care about. Yes, they use similar words, but the content is wrong. It's like in some sense a hand with 6 fingers is close to one with 5 fingers, but it's still wrong. The issue is that we have a different metric for good output than the one that the models use. When I say we, I mean humans, just in case there is some misunderstandings. And these different metrics for what's good are a problem you can't fix by just training a model with more and more input. It's fundamentally missing information about what makes its output good for us. The solution is to teach AI logic and to use symbolic language similar to what most math software uses. If you combine that with a neural network, it's called neurosymbolic. This can fix a lot of problems with large language models, and some of those approaches already exist. For example, I mentioned already in January that DeepMind made remarkable progress with using AI for mathematical proofs. Just last month, they reported that their maths AI now reached the level of a silver medalist in the Maths Olympics. Not only does it solve the problems, it also provides a proof that humans can understand. Well, more or less. The relevant point isn't that AI can solve maths Olympics problems, because let's be honest, who really cares? The relevant point is that this AI can pass the problem and can formulate logically correct answers that a human can understand. Apply this logical rigor to verbal arguments and boom, a lot of problems with large language models will disappear. Imagine an AI that could win every internet argument. Reddit would become a ghost town overnight. What I just told you is neither new nor particularly original. It's been pointed out for decades by many computer scientists, including Gary Marcus and Jean LeCun and others. I just want to say, I think they're right. You can't just train large language models on more and more text and images and hope that it'll begin to understand what's going on. And I think no one really expected that. That said, it's more difficult than lumping symbolic reasoning on top of the already existing models, basically because of what Wittgenstein called linguistic confusion. It's that no two people use a word to mean exactly the same. And once you've lumped together text from billions of different people, logical relations between these words become washed out, if there ever were any to begin with. I mean, it's not like people are all that good with logic. So I'm afraid that the already trained large language models will have to be retrained. Ultimately, the problem with large language models is that the world is not made of words. At the deepest level we know of, the world is mathematics. If you want to build an intelligent AI, you need to start with maths and with models about physical reality and then put words on top of that. What this all means is that companies which have poured a lot of money into large language models might never recover those expenses. The winners will eventually be those who build an AI on logical reasoning and models of the real world like DeepMind. What you see here is a recent example in which they created a virtual mouse in a virtual environment that's moving with its own neural network modeled after a real mouse brain. This, I think, is how you'll get to really intelligent AI. Next up, virtual cats chasing virtual mice across your computer screen during important Zoom calls. DeepMind was acquired in 2014 by Google, so I haven't yet lost faith in my Google stocks. The brief summary is that all those people working on AI need to think less about words and more about physics. Just wait until people start using AI to manage their stocks. It'll be great. The Republican candidate for vice president in the United States, J.D. Vance, has on various occasions said that he doesn't think much of people who remain childless because nothing says vote for me like offending half the population. But his concern is shared by many at a time when the US fertility rate is at a historic low. Is Vance right to worry? And if so, can anything be done about it? I've collected all the facts you need to join the discussion about whether or not childless cat ladies will spell the end of civilization. Vance is somewhat extreme in his views, but the fear that people just aren't having enough babies is not so uncommon. Elon Musk, for example, has said that underpopulation is a much bigger problem than overpopulation, and he's certainly done his part to populate the planet. Not that his fellow fellow Americans care all that much. According to a report from Pew Research Center, an increasing share of childless adults under 50 say they're unlikely to ever have kids. The percentage is now at 47%. That's a whopping 10% more than 2018. And of those who said they're unlikely to have children, 57% said the reason is that they just don't want to. The next common reason is that they wanted to focus on different things and the generally miserable state of the world. Turns out sleep deprivation and diaper changes aren't as appealing as Instagram made them look. A century ago, women had 5, 6, 7 children. Now the fertility rate, that's the average number of children per woman, has dropped below 2 in all industrialized countries. This means that populations decline unless countries accept immigrants. It's interesting that in the United States, the fertility drop happened much later than in all other industrialized nations. Up until 2000 or so, fertility was at about 2. Just exactly why is hard to tell. There were probably several contributing factors. One is that the United States had a lot of Hispanic immigrants, and those had on average more children than the rest. In the early 2000s or so, the fertility rate of the Hispanic population rather suddenly dropped, plausibly because they became better integrated and is now comparable with the average. The other reason is probably that for a developed country, the US used to be a surprisingly religious nation. However, atheism in the United States has more than doubled since the late 1990s, and that might have dampened enthusiasm to be fertile and multiply. This video comes with a quiz that lets you check how much you remember. This decline in fertility makes some people uncomfortable and has given rise to the pro-natalist movement, who basically see their task as having as many babies as possible. Works better if you're a billionaire. But to be fair, having an aging population without young people to take care of the elderly is a social problem. This is why many governments have come up with ideas to encourage people to have more babies. Taiwan has offered tax cuts and free pets, because if you're having a baby, you really also want a puppy at the same time. Italy and Greece offer bonuses per baby. In Hungary, couples get €30,000 if they have at least 3 children. We've also seen a bunch of questionable and often hilarious ad campaigns to encourage people to have babies, like these from Italy. And here is a Danish ad encouraging Danes, in no unclear terms, to do it for mum, do it for Denmark. Guess what? It didn't work. None of these initiatives had any noticeable impact. It's clear that the decline in fertility rate is not about cost or access to childcare. In Northern Europe, childcare is basically free and parental leave is plenty. Still, fertility rates are low. Why is that? Historically, the major reason for the drop in fertility has been a drop in child mortality. Couples had more children than they wanted because they expected some to die. And indeed, despite the many children, populations grew very slowly. But once child mortality dropped, fertility dropped with some delay after it. In that period, when child mortality has already dropped but fertility has not, countries see an incredibly rapid increase in population. The population of China, for example, almost doubled from the mid-1950s to the mid-1980s. A similar thing happened in India. But this transition is not complete in all countries. Scientists still expect a rapid population increase in various currently underdeveloped regions. Estimates say, for example, that the population of Nigeria will increase from currently 206 million to a staggering 791 million by 2100. And Niger will explode from 21 to 185 million by the end of the century. These projections expect the global population to peak in the year 2064 at about 10 billion. Imagine, that's more than the entire cast of Game of Thrones and all their support staff. So you see, pronatalists really don't worry about babies per se. They worry about very specific babies. Because for the time being, population decrease on the global north could easily be made up by immigrants from the south. though by the end of the century this won't work any longer either. But decreases in child mortality are not the only reason people have fewer children. Multiple studies have found that declining fertility is strongly correlated with women's education. It's not just because women learn to use contraceptives, it's that education gives women other options for what to do with their lives, which now compete with childbearing. And that brings us back to the recent Pew survey. People just want to do other things. So, going by historical data, it's extremely unlikely that the pro-natalist movement or government incentives will have any noticeable impact on fertility rates in the United States. That said, I worry about a lot of things, but this isn't one of them. Because in contrast to the global climate, species populations are indeed self-regulating. Keep calm, carry on, and fertility rates will go back up to replacement level. Until then, stop telling other people what to do with their lives, and never mess with childless cat ladies. Physics is so much fun because it combines both the highly practical and the highly speculative. You get everything from the next better transistor to how to properly drag sheep to quantum communication between aliens. Yes, you heard that right, quantum communication between aliens, which explains the Fermi paradox. And that's what we'll talk about today. The Fermi paradox is an estimate by Enrico Fermi, which says that given all we currently know about the universe and the laws of nature, we should have detected signs of extraterrestrial civilizations already. So what's going on? The answers to that riddle have been as numerous as entertaining. Maybe turning goo into brains is harder than we thought. Maybe the aliens are more interested in virtual reality. Maybe we have heard from them, but NASA is hiding it from us. Maybe they're too intelligent to want anything to do with us. Maybe all of that. Personally, I think the reason is that if there are any technologically advanced species, they'd use some communication method that we haven't yet invented and have no way of detecting. And this is where the new paper comes in. The author Latham Boyle from the University of Edinburgh points out that extraterrestrials would have good reasons to use quantum communication, and that it'd be basically impossible to detect. Quantum communication makes use of all quantum properties of particles, in this case photons, the quanta of light. For standard non-quantum communication, the information could be in the wavelength, the polarization, and the number of photons. But if you take into account quantum properties, there's much more you can do with photons. You can entangle them with each other in many different ways, and the more of them you entangle, the more information you can squeeze into them. That's why quantum communication is more efficient at transferring information, or to put it differently, you can send the same amount of information in a shorter message. It's kind of like you can watch this video instead of reading the paper. Quantum communication has another benefit, which is that it's much safer in that you'd know if your message was intercepted. Because if you measure the message while it's on the way, that'll destroy its quantum properties. Finally, quantum communication is the obvious way to, well, send quantum information. If these extraterrestrials have quantum computers and they want to upload their result into the intergalactic cloud, then of course they'd be using quantum communication. That all sounds quite plausible, but would you have guessed it? It's not all that easy. For the quantum information to be preserved while the signal travels, the photons should not interact with anything else, or at least be very unlikely to interact. If they do, say, bump into atoms of the interstellar gas, that'd lead to a loss of coherence and destroy the information hidden in the signal. The risk of that happening depends on the wavelength of the photons. If they're too long or too short, then they're likely to be scattered or absorbed either in our atmosphere or during travel. The author of the paper says that the best signal to use would be in the near infrared, for which the entanglement could be preserved from one end of the Milky Way to the other. But you saw it coming. There is a slight problem. It's that for this communication to work, you need to keep the photon beam very focused. And for that, you either need a very large sender and receiver, or you need repeater stations in between. And when I say very large, I do mean very large. The author estimates they'd have to be about 100 kilometers in diameter. Then again, while 100 kilometers might sound like a very large telescope for us indeed, for a sufficiently advanced species that might not be all that difficult. They just called it the photon catcher and got IKEA to build it. So maybe aliens already have a galactic internet with repeaters distributed all through the galaxy, and we're missing out on it because we don't understand quantum mechanics. How does that solve Fermi's paradox? It's because these quantum signals have to be very focused, so we wouldn't see them in our search for extraterrestrials. Moreover, as Boyle points out in his paper, anyone who has a telescope of that size also has sufficient resolution to see that we don't have a telescope of the same size. They'd know that we can't receive their signals and not send anything our way in the first place. At first I thought, this is nonsense. But the more I thought about it, the more sense it made. The future is in quantum technology, and advanced civilizations will almost certainly be able to build megastructures of one sort or another. You just need to gradually build up robot capacity. So sure, they'd use quantum communication. That said, I suspect there'll inevitably be some losses during the signal transfer, even if the distance is well below the mean free path. Maybe we can detect stray radiation after all. So remember, the truth is out there. It's just encrypted in quantum gibberish we can't understand. Thanks for watching. See you tomorrow.